In this lesson, we're going to review Amazon's AutoScaling and CloudWatch capabilities. AutoScaling gives us linear horizontal scale. It also gives us high availability across individual instances, as well as availability zones. CloudWatch lets us do monitoring and alerting for resources. Alarms can either fire AutoScaling policies, for instance, to add additional instances in an AutoScaling group, or fire SNS notifications to let people know when there's trouble in the infrastructure. AutoScaling, ELB, and CloudWatch make up what Amazon refers to as triangle services. These services are intended to play nice with each other. Instances inside of an AutoScaling group, for example, can fire CloudWatch alarms, which then add instances into the AutoScaling group and let the ELB know to serve traffic to those new instances. You can also fire alarms from the ELB itself for things like latency and request count. To set up AutoScaling, you first need to create an ELB. You need to create instances and balance across them in 2 or more AZs. Create an AutoScaling group that spans those AZs. Create AutoScaling policies in pairs. You're typically going to have one up and one down. Here you can see that for our up policy, we're adding 2 instances, and for our down policy, we're removing 2 instances. Next, you want to create CloudWatch alarms, again in pairs. These are going to fire policies. Here we're saying that when the ELB latency, or the time that it takes the ELB to respond to request, goes above 500 milliseconds, we're going to fire the policy add 2 instances, to add 2 more instances in our backend. And when the ELB latency goes below 100 milliseconds, we're going to fire our down policy to remove 2 instances and save money because we don't need those instances. You don't necessarily have to use an ELB, but it does integrate very nice with AWS. You can also use more than 2 AZs. You can also use even just a single, but it's generally not a good idea. You're going to want to limit how large your AutoScaling group can grow. This keeps you from paying additional dollars when and not if you get a distributed denial of service attack. You can fire policies on a variety of alarms. For example, inside of the AutoScaling group, you can fire on aggregate, EC2 CPU, and I/O, but not RAM. Surprisingly, memory is not something that the VM exposes to CloudWatch. You can also fire on ELB thresholds, such as latency, I/O, and request count, or custom metrics, things such as application metrics, like number of threads or open files. To set up AutoScaling, you need 3 pieces: a launch configuration, which specifies parameters about the EC2 instance itself, such as AMI and type of instance. You also need an AutoScaling group, which defines the AZs, the minimum, maximum number of servers, and so forth. And you need an AutoScaling policy, which are buttons that actors can push. Those actors can be the API, it can be scheduled, or it can be CloudWatch itself. The launch config defines a launch profile, which includes the image ID or AMI, the instance type, for example, a T1 micro or an M1 small. We also recommend that you use a key pair and a security group. The name is very important as well, as this helps you go back and find your launch config later. For example, we would have an image ID of my web AMI, where I burned my web server, an instance type of M1 medium, a key pair of production, a security group of web tier, and a name of web M1 medium, which helps us define exactly what this server is. You can see from this profile here that you can specify additional parameters, such as EBS device mappings, RAM disk ID, spot price, and so forth. You can even put user data into your launch config, which can be very helpful to take a vanilla server and customize it. The AutoScaling group itself defines the container for instances. This includes the launch configuration that you just specified, the AZs, we recommend 2 or more, the minimum size of the AutoScaling group, which is the minimum number of instances that it will contain, the max size, which is the maximum number of instances that it will contain. Regardless of what happens inside of your AutoScaling group, you'll never go below your min size, and you'll never go above your max size. So this helps define some border areas. You can also specify desired capacity. If desired capacity is specified, it, rather than min size, is what's used to determine the size of the group if nothing else is going on. We also recommend a name and an ELB, as well as possibly a cooldown period. We'll talk about that in a second. To put in some actual parameters, we could specify a launch configuration of web M1 medium that we just specified in the previous slides. We can specify the AZs of AZA and AZB. We can specify that our group will never go below 2 EC2 instances and never grow above 20 EC2 instances. But given that no alarms have fired, we'll always try to seek to 4. Again, we're specifying the name of a web tier ASG for AutoScaling group. We're putting in the ELB of web tier ELB, and we recommend that you don't specify a cooldown period here. When we talk about AutoScaling policies in a bit, we'll discuss the cooldown period and why it's better to specify it there. If you want more detail on AutoScaling groups, you can browse this URL, where you can see the full list of parameters available to you. Now let's talk about the AutoScaling policy. This defines the buttons that actors can push. There are 3 types of policies. Fixed size, which always tries to seek an exact size of your AutoScaling group. For example, if you know that you always need 4 servers in this group, it will always seek to put 4 servers in. Demand-based, which grows and shrinks on demand. And schedule-based, which kind of works like a Linux cron job and always fires a scale-up policy at one time of day and a scale-down policy at another. We're going to look at demand-based. To get information on the other types of scaling plans, you can browse this URL. When we set up a demand-based autoscaling policy, we need to specify an adjustment, how much we go up or down. We need to specify an adjustment type, which can be one of 3 types. Change in capacity, which moves us up or down an exact number of instances. A percent change in capacity, which moves us up or down a percentage of instances. And exact capacity, which always seeks to bring our autoscaling group to exactly X number of instances. We also recommend a name and a cooldown period. If we put in some actual values for a policy like this that adds 2 instances with a cooldown of 3 minutes, it would look like this. The adjustment is set to 2. The adjustment type is set to change in capacity. The name would be scale up by 2, so we can easily find it later. And we can set the cooldown to 180. Cooldown is specified in seconds. What the cooldown period does is says that inside of this period of time, the autoscaling group will not honor any request to scale up or down. We generally want to try to scale up aggressively and scale down conservatively. We'll talk about that in a bit. Let's look at another policy, where we may want to remove 10% of the instances with a cooldown of 5 minutes. Here we'd specify the adjustment as 10, and the adjustment type of percent change in capacity means that 10 is a percentage of the overall number of instances. For example, if we had 20 instances in our group, and we scaled down 10%, we would lose 2 of those. The name could be scaled down by 10% for easy identification later, and the cooldown can be set to empty. 5 minutes is the default cooldown period. Again, if you compare this with the scale-up policy that we just wrote, we're setting our cooldown period on scale-up to lower than our cooldown period on scale-down. This is saying that our scale-up can happen faster than our scale-down. Some good best practices with autoscaling policies is to always create pairs, and always go up or down a factor of the number of AZs. If you have 2 AZs, then scale up or down by 2, 4, 6, 8, and so on. And if you're scaling across 3 AZs, then go up by 3, 6, 9, and so forth. Try to scale up aggressively and specify a short cooldown period in your scale up policy. And try to scale down conservatively and specify a longer cooldown period on your scale down. Again, you can specify this in your autoscaling group. In that case, it would apply to both scale up and scale down events. Try to give descriptive names to everything so you can easily find it later. Let's talk about CloudWatch a bit. CloudWatch monitors and alarms on resources. The resources can be inside of AWS or outside of AWS, and the basic monitors are provided for free with most services such as EC2, ELB, and so forth. There's also advanced monitors that incur additional charge. Alarms can fire autoscaling policies or SNS notifications. CloudWatch is statistics in and statistics out. And what I mean by that is if we look at our raw data coming from our ELB, let's say that every 5 seconds we have data that looks like this. We see that the ELB latency for one request was 326 milliseconds. The next request was 180 milliseconds. The next request was 452, and so on. 5 seconds later, we see that this number of requests came in with this number of millisecond latency. And 5 seconds after that, we see these numbers come in. CloudWatch flattens that into these variables: a sample count, which is the number of samples that were taken at t0, the max, which is the maximum value of any of our data points, the minimum, which is the minimum value of any of our data points, an average of all of the data points, and a sum. CloudWatch exposes these variables as statistics to you, and this is what you see in CloudWatch, not the raw data itself. Let's look at some CloudWatch terms. CloudWatch uses namespaces, metrics, statistics, units, periods, and alarms. And if we look at these in the web GUI, we see that the namespaces, for example, for AWS, are AWS/service name. The metrics are specified here in the upper view of CloudWatch, and here we can see that we have CPU utilization, network in and network out for EC2. Statistics are specified down here, and if I could select this drop-down box, I would also see sum, min, max, number of samples, and so on. The units depends on the type of metrics being measured. For example, CPU utilization is in %, but ELB latency is in milliseconds. And the periods are specified down here. CloudWatch alarms can trigger when a metric statistics either goes in or out of its threshold for a specific time. They can fire an AutoScaling policy or an SNS notification, or both. For example, if we have average CPU utilization at 80% for 5 minutes, and we want to fire an alarm on that, the metric that we're looking at is CPU utilization. The statistic is the average rather than the sum. The state is 80%, and the specific time is 5 minutes. To use EC2 metrics, you have to install the CloudWatch agent inside of EC2. You can do this easily with just a checkbox when you're launching an instance from the web GUI. AutoScaling group EC2 metrics are aggregated across all of the values for all of the instances in that group. For example, CPU utilization is the aggregate of all CPU utilization across all instances. So the average CPU utilization at over 80% for 5 minutes actually means the group CPU utilization at over 80% for 5 minutes, something that we can alarm on. Again, the alarm can fire a policy, such as scale up by 2 that we just created in our AutoScaling groups, and or send SNS. It can also do some other things, such as kill an instance for EC2, stop an instance for EC2, and other things depending on the resource itself. AutoScaling unfortunately has no web GUI, and you'd have to install the command line tools to work with it. CloudWatch can also do billing alarms, and we highly recommend that you go into this URL and set up a billing alarm. In our case, we set an alarm so that we're notified via email when our AWS bill goes over $10. Custom metrics are very expensive, and we recommend exporting these metrics to offsite into your own Nagios or Ganglia. That was a quick overview of AutoScaling and CloudWatch, but at this time you should have a firm understanding of all of these concepts.